Can you guys show me how it works?
So what Brian's doing here is he's running the polar fuzz tester, and what it's doing is generating random policies and then random sets of facts for those policies. And then it makes two different queries that we've constructed, which should always return the same set of results, assuming that everything is working correctly. And if that doesn't happen, then we've found an edge case. So what you'll see is that we will find an edge case, and then the fuzzer is going to return the minimal fake policy and random set of facts that was able to trigger that bug. And now we have a unit test that we can add to our code base for perpetuity.
So, Jesse, why did you create the curse policy generator?
So we currently have lots of unit tests for Polar, the programming language, and all of those pretty much were found, were specific edge cases that either a user or an engineer found while working on like a new feature. So we discover an edge case, add it as a unit test, and then in the future while we're working on the language, we know that we're not going to break that test and introduce some kind of regression. But obviously those are only edge cases that like people have actually found, and the that represents only like a teeny fraction of like possible polar policies that our users can write. So the curse policy generator was our way of trying to actively like seek out very cursed and spooky policies that would hopefully break the language in ways that no one using it like a normal person ever would, to make the test suite more robust.
So, how did you fix that problem?
So the technique that my colleague Brian and I used to solve this is called fuzzing, which is a technique where you generate random bytes and stick them into your computer program and try to break it essentially. Except you're having a computer do this very rapidly. Fuzzing a programming language like Polar is a bit more complicated than fuzzing a URL decoding library. For the URL decoding library, you just generate random bytes, stick them in, and then if it breaks, like seg faults or something like that, then you've found a bug. Polar requires the input be a bit more structured, and we're not interested in testing that our parser is able to differentiate between random bytes and valid Polar. We're trying to test the actual underlying logic engine. So that requires that the random input that we're generating be more structured than it typically would be for a more fuzzing a simpler program.